Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is probability. In this video, we'll be focusing on NCERT solution for exercise number 1. In the first problem, a die is rolled. Let E be the even die shows 4 and F be the even die shows even number. Are E and F mutually exclusive? So whenever such probability questions are there, the first step is to write the sample space. Sample space means all the possible outcomes you have to write. So when we throw a die, all possible outcomes could be 1, 2, 3, 4, 5, 6. Please remember a die has 6 faces. So and a number is written on each of them. So it could be either 1, 2, 3, 4, 5 or 6 when we roll a die. Now in the first event called as event E, it shows for die shows 4. So we'll write it as 4. So the possible outcome for event E is only 4. Similarly for event F, the die shows even numbers. So out of the sample space, we have to collect the even numbers. Which are the even numbers? 2, 4, 6. So event F will be 2, 4, 6. Now are E and F mutually exclusive? What is mutually exclusive means? There is no common elements between E and F, but we see a common element 4 between them. So they are not mutually exclusive. So how do we write them? We first find E intersection F, then 4 and 2, 4, 6. The common element is 4. Since E intersection F is not 5, not 5 means not a null or an empty set, 4 is there, so they are not mutually exclusive events. Suppose there was no common element between E and F, then they would be mutually exclusive events. But in this particular case, E and F are not mutually exclusive events. A die is thrown. Describe the following events: A number less than 7, B a number greater than 7, and so many problems are there in this question. We'll do one by one. So let us take a number less than 7. A die is thrown. Again, first step is to get a sample space. So sample space is all possible outcomes. So when we throw a die, the possible outcomes are 1, 2, 3, 4, 5, 6. This is the sample space. Now all the events will be based on the information from the sample space. We have to pick those numbers from sample space corresponding to the question. For example, a number less than 7. So from sample space, which numbers are less than 7? All the numbers are less than 7. So the event A will be containing the set 1, 2, 3, 4, 5, 6. The second part, a number greater than 7. So the sample space is 1, 2, 3. From this we have to pick a number greater than 7. In fact, there is no number which is greater than 7 from in the sample space. So the B will be an empty set or a null set. In the third part, and event C, a multiple of 3. So the sample space is this, and what is a multiple of 3 from this sample space? 3 and 6. So the event C will be 3 and 6. D, a number less than 4. From the sample space, which numbers are less than 4? 1, 2, 3. So D event will be a set 1, 2, 3. E, an even number greater than 4. So from the sample space, which numbers are greater than 4 and even also? So greater than 4, only two numbers are there, 5 and 6. Out of that, which is even? 6 is even. So E will be a set corresponding to the element 6. F, a number not less than 3. Which numbers are not less than 3? 3, 4, 5, 6. So F event will be containing a set 3, 4, 5, 6. Also we need to find A union B, intersection B, and so many. Let us try to understand this. Now A is given by this set and B equal to 5 or a null set. The union will be A itself because B is 5. So A union B is A only, which is the set 1, 2, 3, 4, 5, 6. A intersection B is 1, 2, 3, 4, 5, 6 and B equal to 5. What is the common element? Intersection means common elements between A and B. There is no common element. So A intersection B is 5. B union C. So B equal to 5, C is 3, 6. A, B, C we have computed previously. So B union C will be 3, 6 itself. E intersection F, E is 6, F is 3, 4, 5, 6. So what is the common element? Because intersection we are trying to find. 6 is the common element. So in E intersection F is set 6. Now let us find D intersection E. D is given 1, 2, 3. E is 6. So intersection means find the common element. There is no common element. So D intersection E is 5. Now A minus C. A is given by this set and C is given by 3, 6. So A minus C is from A, remove the elements corresponding to event C. So 1, 2, 3, 4, 5, 6. C is 3, 6. So from this we will remove 3 and 6. The balance elements will be 1, 2, 4, 5, which is corresponding to A minus C. Let us take D minus E. So D is 1, 2, 3, E is 6. So D minus E is from D, remove the element corresponding to 6. But there is no 6 in this. So this will remain D it is, which is 1, 2, 3. What is this F apostrophe? F apostrophe means F complement or not F. F is 3, 4, 5, 6. Sample space is 1, 2, 3, 4, 5, 6. So F complement or not F means from sample space remove the elements of F, or F apostrophe is S minus F. From sample space remove the elements F, or in simple words we call it as not F. F is given by this, sample space is given by this. Find a set not corresponding to F, not F. So which is 1, 2. Because this is F, the balance elements are 1, 2. An experiment involves rolling a pair of dice and recording the numbers that come up. Describe the following events. A, the sum is greater than 8. B, 2 occurs on either side. Let us try to solve this. Which pair of these events are mutually exclusive? So first we will find the sample space. Sample space means what are the possible outcomes? What are these numbers? The first number inside the bracket indicates the number obtained by throwing dice 1. Similarly, this is dice 2. So first 1, 1 indicates 1 appearing on die 1 and 1 appearing in die 2. Second option could be 1 appearing on die 1 and 2 appearing on die 2 and so on. So this is the sample space which we are getting. All the possible outcomes when we throw a pair of dice or 2 dice. Now the first question is find the event sum is greater than 8. Greater than 8 means sum is 9, 10, 11 and 12. So all the possible outcomes is A equal to 3, 6, 4, 5, 5, 4, 6, 3, 4, 6 and so on. If we add these numbers, this will be either 9, 10, 11 or 12. Let us see 3 plus 6, 9, 4 plus 5, 9, 5 plus 4, 9, 6 plus 3, 9, 4 plus 6, 10. So all these numbers sum is greater than 8. That is what the first event. Now second event is 2 occurs on either die. 2 occurs on either die means it can appear on first die or in second die or both dice. So the possible events are 2, 1, 2, 2, 2, 3. We see that 2 is occurring at least on one of the die. It can also occur on both the dice. The sum is at least 7 and multiple of 3. So sum can be 9 or 12. Okay, the sum is at least 7 and multiple of 3. So sum minimum 7 means it can be 8, 9, 10, 11 and 12. But it should also be a multiple of 3. So the sum has to be either 9 or 12. So if we take from sample space all those combination, we'll get C as this set. So So let us try to add this. 3 plus 6 9, 4 plus 5 9, 5 plus 4 9, 6 plus 3 9, 6 plus 6 12. So the sum is either 9 or 12. Now we also need to check which pair of these events are mutually exclusive. Events are mutually exclusive, they do not have any common element. This we have seen earlier also. Two elements are mutually exclusive, there should not be any common element. We see that A and B does not have a common element, so they are mutually exclusive. Similarly, B and C also does not have a common element, so they are also mutually exclusive. Let us see A and C. If we take A intersection C, we do not get a null set, we get these values. So it means A and C are not mutually exclusive events. Three coins are tossed one. Let A denote the event 3 heads show, B denote the event 2 heads and 1 tail show, C denote the event 3 tails show, and D denote the event a head shows on the first coin. Which events are mutually exclusive, simple and compound? Let us try to understand this. When we throw three coins, we can get head or tail, and these are the various combination or the sample space. What does it mean? It means H means head and T means tail. It means first could be head, second could be head, third could be head. Here first means head, second coin head, and third is tail. Like that we get different combinations like this. Which events are mutual events? First we need to find A denote the event 3 heads. So we write A equal to 3 head. This is the event. Then B denote the event 2 heads and 1 tail. So the various combinations with 2 head and 1 tail is this. We see 2 head and 1 tail, 2 head and 1 tail, and 2 head and 1 tail. C is denote the event 3 tails. So we get 3 tails. D denote the event a head shows on the first coin. So first should be head. Then others can be anything, either H or T, and these numbers are taken, or these alphabets combination is taken from the sample space. So let us take A intersection B, which is 5. So A is triple H and this is B. They do not have a common element. You may be wondering, here H is there, here also H is there. We should take this as one unit because there are three tosses of a coin. So HHT is a one unit, HTH is a one unit, and THS is another unit. This should be compared with triple H, not one H to be compared with H. So we see that there is no triple H in this right hand side. B does not have any triple H. So they do not have any common elements. So since they do not have any common elements, they are mutually exclusive events. Now let us understand simple and compound events. Simple events means if an event has only one sample point in sample space, it is simple event. So we see that A is triple H and C is triple T. What does it mean? Why they are simple? Because in the set they have only one unit. This triple H is one unit. There are no other units present in set A. Similarly in set C also only one unit is there. So A and C have only one element. So they are called simple events. Now next we will see compound events. In compound events, event has more than one sample point. So we see HHT, HTH, THS, they have more than one sample point. So they are the compound events. Events B and D are compound events. Three coins are tossed. Describe two events which are mutually exclusive, three events which are mutually exclusive and exhaustive. We'll try to see this. Now, since three coins are tossed, the possible outcomes are this. This we have seen in previous problem also. HHH, head and tail. H is by denoting head and T denoting tail. Two events which are mutually exclusive. We see that A getting only head is this. B getting only tail is this. They do not have any common elements between them. So A and B are mutually exclusive events. We need to find three events which are mutually exclusive and exhaustive. Now a new term is coming here, exhaustive. What does it mean? Three events means we have to find three sets such that they are mutually exclusive. They do not have any common elements between them. And if we add all the three events, then it should become the sample space. So if we take A, B, C as the three events, A union B union C should be equal to sample space, then it becomes exhaustive, and A and B, B and C, and A and C should be mutually exclusive. So let us take this example. Let A be the event getting exactly two tail comes. So A will be denoted by this. Similarly, B getting at least two head will be denoted by this. C getting only tail is this. If we see that there is no common element between A and B, we don't see any common element. Similarly, between B and C, there is no common element. And similarly, A and C also doesn't have common element. However, if we take A union B union C, we get S. So hence we can say that these three events A, B, C are mutually exclusive and simultaneously exhaustive. We see that A union B union C is equal to S also. So they are exhaustive events also. The second part, two events which are not mutually exclusive. So let us try to understand this. Let A be getting at least two heads given by this, and B be the event getting only head is given this. We see that triple H is common in both these events. So A intersection B is not phi, not null set. So they are not mutually exclusive events. The next part, two events which are mutually exclusive but not exhaustive. So A and B we take getting only head and getting only tail. We see A intersection B is phi. So they are mutually exclusive, but A union B is not equal to sample space. A union B is not equal to sample space. Sample space, we see that 8 events were there. This has only 2 points. So A union B is not equal to S, so they are not exhaustive events. However, A and B are mutually exclusive events. In this problem, two dice are thrown. The events A, B, C are as follow. A getting an even number on the first die, B getting an odd number, and C getting the sum of the numbers on dice less than 1. We need to describe these events. So this is the sample space which you have seen earlier problem also. These are the all possible combination when we throw two dice or a pair of dice. In the first problem, getting an even number on the first die. So we select all the numbers from the sample space, all the pairs from the sample space in which the first number is an even. This is the first throw of dice 2, 4, 6, 2, 4, 6, 2, 4, 6, and remaining numbers can be odd or even by the second pair. These are the all possible outcomes for the event A. Similarly, for event B, getting an odd number on the first die. So we select from the sample space all those numbers in which the first number is odd number. So we see 1, 3, 5, 1, 3, 5. However, second number can be even or odd. Is not a criteria. Then in the third problem, see getting the sum of the numbers on dice less than or equal to 5. So from the sample space, we take all those pairs whose sum if we add will be less than or equal to 5. So 4 plus 1 less equal to 5, which is less than or equal to 5. This is 4. Again, this sum is 5 and so on. So these pairs are taken from the sample space. Now we need to find A naught or A complement, which is not A. So from sample space, select those pairs which are not A, which are not in A. So we or not A, do not include A. So A is given by this. So A complement or not A will be S minus A. We have seen this earlier definition. So from sample space, remove all the elements of A. We get A complement as this, which happens to be equal to B. Similarly, if we have to find not B or B complement, not B or B complement is S minus B. From S, remove all the elements of B. So we get not B as this, which happens to be equal to A. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.